A red and yellow die are thrown, and the events A, B and C are defined as follows. Event A is the yellow die shows a 5. Event B is the sum of the scores of the two dice is 5. And C is the red die shows a 5. We want to find the following probabilities. So the probability of A, the probability the yellow die shows a 5, well, that's just going to be 1 in 6. If we look at event B for the probability of that, the sum of the scores is 5. Well, let's think how many ways that can be done. We could have a 1 and a 4, a 2 and a 3, a 3 and a 2, and a 4 and a 1. So that's 4 ways out of 36. There's 36 possible combinations of the two die. Think about a grid. We've got 1 to 6 here, 1 to 6 here, so we'll end up with 36 things in here. So that's 1/9. That's the probability of B. And then C is the red die shows a 5. So the probability of C is just going to be symmetrical to this one, so that's going to be 1/6. So what about the probability? So we're on to part 4 now. Probability of A and B. Well, that's simply got to be 0. It can't happen. If we look at event A, the yellow die shows a 5. Well, the only way we could then get a sum is for the other die to show 0, and there is no 0 on the other die. So that one can't happen. B intersection C, well, that's also 0 for the same reason. This one says the red die shows a 5. Now, if we come to 6, that's the probability of A and C. So if we think back to our grid where we have 36 possible outcomes, one of those outcomes would be where this die shows a 5 and this one shows a 5. So that's just one outcome out of 36. Now if we look at part B, which event is mutually exclusive to A? Well, we get the answer from here. So B would be mutually exclusive. If we get a 5 on this die, we can't possibly get a total of 5. Which event is independent of A? Well, that would be C. Whether we get a 5 on the first die or not, so whether we get one on the yellow die, won't affect the red die. So C is independent of A.